Okay, so in this question, we're now going to have a pentagonal area and we wish to maximize that area when the sides that you build are less than 12. So I've got find the maximum area possible when you only have 12 meters less of timber. Okay, so my area in total is going to equal the area of W, what we had in a previous part of the question, which is this, because that happens to be this rectangle here, and that rectangle is the same as what's on the bottom. That's going to be W times 12 minus E to the W on 3 minus E to the W on 2, plus we have this area of this triangle. And I'm going to do a half times length times height. That's a half. My length will be this length here, which is 12 minus E to the W on 2 minus E to the W on 3. And the height's going to be this height here, which is G4 minus W. So 6 log rho E of 2 minus W, and that is the area of the top, the area of the total. The condition that we have is that W plus W plus this side length A plus this side length B, that 2W plus A plus B has to be less than or equal to 12. And if I could get the values that W could be, then I could limit this to what W can be, and then we can maximize this on the calculator. So 2W plus A, well, A is, okay, so this is A, and it's going to be, using Pythagoras' theorem, this is my value of this part of the triangle, this is the value of this part of the triangle, so it's going to be 4 minus E to the W on 3 squared plus 6 log base E of 2 minus W squared plus B, which is this one over here, which is 8 minus E to the W on 2 squared plus 6 log base E of 2 minus W squared. And I want that to be less than or equal to 12. Okay, so I'm going to put that on the calculator. So I've entered our condition. So I've got 2x, which is our 2w, and we've got the first square root, which is a, and the second one, which is b, and I've got that expression. I'm now going to, I've got my expression for the perimeter, and I've graphed it in green. I've got 12 in pink. So if I do analysis G solve intersection, I can see that W has to be W's got to be between 2.638 314 and between this second intersection point 4.006. Sorry, 6005. So that's my range for W that I'm going to limit and maximize this particular expression. So now I'm going to type this expression in. So I've typed my A of W, and that's X times the length L. And then I've got my triangle up the top, which is a half. That's my base, which is the length, and that's my height. So I'm going to Take that. Now I'm going to do my answer and I'm going to maximize it. Interactive calculation Fmax. And I'm going to maximize it from 2.638314 through to 4.6005. And that gives me a maximum area of 19.88. Is going to be the answers.